In this example, we have to arrange 4 boys and 4 girls in a row. There are different conditions given, so let's treat them as different questions. The first condition is such that all 4 girls are together. A very standard question in which few objects have to be clubbed together. Whenever things have to be together, a standard approach is that you just club them together. So let's say these are girls, so the 4 girls, we just club them together, or think of that we tie them and we consider them as just one single entity. And I have the 4 boys, which obviously are distinct. Let me name them as B1, B2, B3 and B4. And I need to arrange them. Since all the 4 girls are treated as one entity, I basically have 5 entities right now, and the 5 of them could be arranged in 5 factorial ways. But is this my final answer? 5 factorial, these are 120 ways. So in these 120 ways, one of the way randomly I'm picking up is, let's say, boy 3, boy 2, boy 4, and then there's this group of girls that we treated as just one entity, and boy 1. Now this is just one of the 120 different ways. This we have treated it as a single object, but there are 4 girls there. Can the girls arrange among themselves? Yes. So for this entity, there can be further many different ways, with the boys being same position but the girls changing positions. Now the girls are 4 in numbers and there are 4 positions, so they could be seated in 4 factorial different ways out over here. Could I say each of them is going to branch out into 4 factorial ways? So my answer is going to be 5 factorial into 4 factorial. A very standard approach. I don't find students having any difficulty out over here, so will not pursue this thought more. The second question in the same type is such that no 2 girls are together. This will take some time for us to solve. While you may not think this way, but many beginners make an error considering that we have already found the 4 girls being together. We want here they are not together. So why don't we just take a complement? What do I mean by complement? Let's arrange them in all possible ways. 4 girls, 4 boys, every possible way. There's no condition given, which is as good as 8 objects, 8 positions, that is 8 factorial ways. From these, let me remove off, take it away. Which ones? The ones that they are together. 5 factorial into 4 factorial. Is this going to be my answer? Let's see. What have we removed off all the case? When the 4 girls are together. So arrange them. I see an arrangement, all 4 are together, take it off. I see another arrangement, all 4 are together, take it off. What I will be left with, is that going to satisfy no 2 girls being together? Think not really. This is an answer for all 4 are not together. Whereas we want no 2 girls should be together. So 4 of them together I've taken eliminated, but would there be cases left where 3 girls are together and 1 is separate? Or 2 of them could be together, another 2 could be separate or yet together. So this is not going to be my answer for this question. Right? So this is the tricky part in this question. Not many people, as I said, think this way. However, there is yet another error that quite a few commit in this. That goes something like this. Since, it says no 2 girls should be together. No one, they should all be separated. So the only way that can happen is girl, then there's a boy. A girl could come in, another boy. So one starts thinking of they need to be alternate. However, remember, that is a third question. In how many ways can the 4 girls and 4 boys be arranged such that girls and boys are alternate? girls and boys are alternate in the seating arrangement. If girls and boys are alternate, this is an easy one. Either I am going to have, starting with a boy, a position fixed for a boy, then a girl, boy, girl, boy, girl, and a boy, girl. So the boys should only be seated in these 4 positions. And so 4 positions, 4 boys, so they could be seated in 4 factorial ways. The girls, there are 4 specific positions for the girls, 4 girls, so they could be seated in 4 factorial ways. And there could be another situation here, which is going to be starting with a girl, girl, boy, girl, boy, girl, boy, girl, boy. Right? Again, this will have a similar logic, 4 factorial into 4 factorial. And one of the 2 cases will happen, either the first one or the second one. So we would be adding this, or in short, the answer here is straight. 4 factorial into 4 factorial into 2. Quite a few of us are aware of this. We are still left with this question. Is the second question exactly similar to the third question? Let's see, no 2 girls are together. In both of these arrangements, no 2 girls are together. They are always separated by a boy. Yes, but what is wrong is, alternate means girls should not be together, also boys should not be together. Whereas the second question only mentions about girls. The boys could be together. Is that possible? Pretty much. For example, I'm just listing out. Let's say it starts with a girl. Let's keep 2 boys together. And could I have this possible arrangement? That makes it 4. Yes. So none of the girls are together, but the boys could be together. At the same time, they are not alternate, right? So these questions with these arrangements also have to be included along with the below, along with what we found here, right? So rather, the third question is a subset of the second question. So how do we solve this second question? Now, almost all students immediately think when people have to be together, they immediately tie them up and consider them as one object, right? Similarly, no 2 are together. Also, there is an absolute standard approach that you need to follow, and that standard approach is arrange others first. Others, by others I mean some things need to be kept separate, forget them, arrange others first, and then arrange these, the ones who need to be separate, in gaps. So this is your standard approach. So girls should be kept separate, so arrange the boys first. So fix positions for the boys, 4 different positions. Let's say the boys could be arranged among themselves in 4 factorial different ways. And now focus on the gaps. So which are the gaps left? There's a gap here, first, second, third, fourth, and fifth. There are 5 gaps, and we have 4 girls. The girls, 1 could go in each of the gaps. So the first girl could go in any of the 5 gaps. We have 5, so that would be 5 different ways for the first girl. Let's say the gap is chosen, the first one itself. Now the second girl has 4 different positions. She could select a position in 4 different ways. So let's say the second one has selected in 4 different ways. The third one has 3 different positions. She could select a position in 3 different ways. Let's say this is filled up. Now for the fourth one, look carefully. There are 2 positions left, and she could choose her way in 2 different ways, right? Whichever. If she had chosen this position, then this is going to be an arrangement nothing but like alternate girls and boys. However, could the girl have also chosen the last position here? Pretty much. That is why there are 2 ways in that case, right? In which case, the 2 boys become together. Remember, there's no such thing called a virtual gap or so on, or a space vacant out of there. We are just saying among themselves the 4 boys could be in 4 factorial ways. And the gap, so if a girl is going to sit in a gap, they could just separate out and there's a position created. In all different ways that we are looking at relative to each other. There's no such chair or a gap left out over here. So the answer is going to be 4 factorial into 5 into 3 into 2. Which quite a few students do this as 5 factorial. However, I'd ask you to resist that. It is just dependent upon these numbers. Hope you have got the different scenarios of arranging people. Common ones, being together, being alternate, pretty easy ones, and no two being together where you need to think a little. The answers to this also depends upon the numbers used. So let's quickly see how these situations change if the numbers change. If I would have 5 girls, let's do the case of they being alternate, girls and boys being alternate. Now remember, there are 5 girls, and if the girls and boys have to be alternate, it has to start with a girl, then boy, girl, boy, girl, boy, girl, boy, and that is 1, 2, 3, 4, and another girl. So the first one also will be a girl, second one, last one will also be a girl. And so there are 4 places for the boys to sit among themselves, that is 4 factorial ways, 5 places for the girls to sit, that is 5 factorial ways in that case. So this is the answer. This time there is no 2. Because you do not have any other case. We could not have started with the boy. The first and the last has to be girl. And let's say another question here such that no 2 girls are together. No 2 girls are together. No 2 are together. Arrange the boys first. So the 4 boys have been arranged in 4 factorial ways. And now how many? There are 5 places and there are 5 girls, which will straight be 5 factorial ways. There's nothing which is going to be left. So what we see this time is both these cases are identical. They are not distinct like the previous ones. Both of them have the same situation, right? And yet to wind up, let's increase one more number out over here. Let's say there are 6 girls. The alternate case is easy, so let's finish this first. If girls and boys are alternate, is it possible?
Just 4 boys.
So the 4 boys could separate out 5 girls, but one of them has to be together. So not possible. Similarly, no 2 girls are together will also not be possible. And can we get this answer through just by continuing our approach? Yes. The 4 boys are seated together and these boys will create only 5 different gaps. There are 5 gaps, but we have let's say 6 girls. So this is not possible, and hence 2 girls necessarily have to be together, right? However, if this question was no 2 boys are together, we have just seen this earlier, the boys need to be separate. And if the boys need to be separate, arrange the girls first. The 6 girls could be arranged in 6 factorial ways. And with 6 girls arranged, you should ideally not draw. Let me just say 6 girls arranged would result into how many gaps? Would result into 7 gaps, including the initial and the final position. And out of these 7 gaps, we just have 4 boys, so they could choose their position 7 into 6 into 5 into 4. And that is why I said don't look at this as a factorial. It need not always be a factorial. In a first case, it was same as 5 factorial, but not in this case, right? So this takes care of all arrangements of people. And next we will move ahead and check how do we arrange words.